Hello, everyone. Thank you for joining us on this very special day. My name is Matthew Daniel, product manager for the 48 volt product line of Fortress Power. I'm here in Langhorne, Pennsylvania. Very excited to give you the eForce unboxing, installation, and commissioning webinar. But before we get started, I just wanted to do a mic check, see if you guys can hear me clearly. Just leave something in the comment section. James Waters, thank you. Chuck, Darren, thank you. Thank you, everyone. Okay, perfect. Let's get started. All right, I'm going to give a brief introduction. For those of you who don't know about the eForce, right? It is a 48 volt nominal battery, 15 cell battery, okay, with a 200 amp capacity per module. So that would be, to my laser pointer, each module of these is 9.6 kilowatt hours. And what you're seeing right now is 19.2. It is a 1C rated automotive cell industry. 1C rated cell from the automotive industry, and we've taken the same that we use from eFlex, eFlex Max, and eVolt Max as well. The recommended charge is 120 amps and 160 amps on the discharge side. But again, however, one module can charge 190 amp continuously and discharge as well. There are some limitations when you're stacking vertically, but if you need that more power output, you basically stack one of the modules to the side. And we call it a horizontal paralleling system, right? Essentially, it's like treating the battery like an additional battery, right? And so both of those batteries would get 195 amps continuously times two, right? Has a cell failure rate of 0.02%, and that's data extracted from our 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 our, our existing product, which is the eFlex and eVolt Max. It has a very low failure rate, and that has to do with more like cell imbalances. And it comes integrated with eStop. Basically, it will when you enable rapid shutdown, it's not only going to turn off or disengage your PV output, but it's also going to disengage your inverter output as well to make it safer for first responders to uh, you know go into the premise to the property. It is CEC listed, and it will soon be listed as an ESS in the CEC as well. So about 2 more weeks. And it is UL 9540 DC ESS, which, according to the third edition of the UL 9540, it allows me to basically certify the system, just the battery itself, as an ESS without the inverter. And we can have another session going over the UL 9540 that explains the new definitions of ESS and that it accepts ACESS or DCESS. In ACESS, the output of the ESS is AC. In DCESS, the DC output or the output is DC. So you could basically take this battery and couple it with another inverter as long as the inverter has the latest UL 1741 certifications. Moving forward, sorry. Um, so to describe in briefly, right, you have the base, battery, and the eWay, which base and eWay function to close the circuit on the battery, right? Going inside the eWay, you have the communication ports, right? And it allows you to select the inverter protocol, do battery to battery communication, and battery to inverter communication, right? It is not a BMU, right? So the beauty of this battery is that each module has individual BMS, and the eWay is just closing the circuit, but it's really serving as a wireway. Short, that's why we call it eWay, right? Where it also has a 750 amp bus bar to serve to parallel battery to battery, and then make the connection from battery to inverter to the battery ports of the inverter. You also have your side knockouts to run your AC and your DC wire, and then a slot to basically hook up or install the Guardian that will serve as your monitoring platform for both battery and in March battery inverter as well. And then this is your power switch, which basically shuts off the battery, but it also will serve as the e-stop. Okay. Okay. Unboxing. Unboxing. All right. We're gonna go through each components, right? When you're unboxing the battery itself, which is the 9.6 module, you're found with the battery. You're found with wall fixing brackets, basically to fixate the battery against the wall, right? Side braces, when you're installing battery to battery, that we secure it on the side. And then your nuts and bolts, right? And then eWay, which is a separate package, right? You have your eWay, your side braces, the base, right? Template. This is gonna be your installation templates, what you're gonna use to install or to make sure you're having the right configuration, whether that's wall floor mounting or floor mounting fixated against the wall or wall mounting, right? And then as well as the MV, if the MV sits on top of the eForce. Um, there's a key, right, that unlocks the eWay just for more security purposes. Stainless steel legs for the base, a battery to battery communication cable, and a battery to inverter communication cable. And then you have a terminating coupler similar to the eFlex. For those of you who have been with us, uh, the eFlex has a terminating couple, basically that terminates battery to battery communication. And then there's a relay cable that will be connected if you're using eWay with eWay. So basically you have a stack here and another stack in parallel, and it will enable so that when you're commissioning the system, you just power on the master battery and that will propagate the information to the others and it will turn it on without having to turn on the switch on the parallel batteries. And at the same time, if you want to turn off your system, let's say for a rapid shutdown, uh, you only turn off the master, and that will also disengage the other batteries. And then your nuts and bolts. We have optional accessories, right? So if you actually want to wall mount the battery, so suspend it up from the floor, we do provide an optional accessory, which is the wall mounting kit. This would be your wall bracket. This would be your battery bracket. And then this will be your L-shaped brackets that will go on below the base. And then your nuts and bolts. And then the MV front panel, um, which basically serves to give a more aesthetic appeal, all-in-one feel to the system. That will cover the MV. And an additional function will be to protect the LCD. Let's say if you're installing in the south side, you can also use that cover as well and would not void warranty. Pre-installation. You guys still hear me? Just want to confirm that we are good. Great. Thank you. Thank you, guys. James, Milo, thank you. Okay, minimum spacing requirements. This is more abstract, extracted from the UL testing, right? We gave 8 inches from eForce to eForce, and then 6 inches from eForce to wall, and then 8 inches from eForce to inverter, right? And then per UL and FPA, make sure you have your 36-inch clearance from the battery to from the front of the battery. There can't be anything within those 36 inches, right? So that would be 3 feet. And then 58 inches from the wall, although the brackets that we talked about, the wall fitting brackets. So let me go back. These wall fitting brackets will already give you that space constraint, so you don't have to worry in that measurement. Okay, and these are the maximum space requirements where you're wall mounting, right? So the battery being suspended from the floor. Let's say you're installing one battery, right? This is also one of the beauties of the system is that for jurisdictions where have flood zones, you have to install 3 feet above ground. You can definitely go with two of these, and you will get your 19.2 kilowatt hour battery system. But what we do is from the L-shaped bracket, right, from the bottom of it to the floor, you should get around, you should measure 42.56 inches, right? Um, right, to meet that those would be the maximum requirements, especially if you're installing the, I'm sorry, disregard that. Sorry. Um, then you have two batteries. If you're installing two batteries, this would be the maximum distance, so it would be 23 inches. And then if you're installing one battery with an inverter, it would be 21.5 inches. And that's just to make sure you don't surpass the NEC code, right? That you don't surpass the height that requires NEC code, that your disconnect cannot be 6.7 feet or more, right? And that would be this guy right here. So this would be your PV switch from the MV. So if you do this measurement, right, if you install it in this way, this will guarantee that this disconnect is not going to surpass 6.7 from stated from the NEC code. And then if you're doing two batteries with an MV, same thing. You would then leave maximum 2 inches from the floor. And then this your uh, basically your wall mounting bracket dimensions. And again, all of this information is extracted from the manual. So basically, I'm just going over the manual with you guys and give you pointers and hints of any special considerations that you might need to take. But all of this again is extracted from the manual, and if you need these dimensions, you can just go back there. All right, these are all your options, or all the configurations you can do with the eForce, right? So you can do floor mount. When you're doing floor mounting, you have these options, right? You have two batteries, an inverter with the MV front panel. You have two batteries and the inverter on the side. Two batteries and an MV without the cover, and then two MVs with the inverter uh, without the cover, but on the side as well. And these are a lot of your paralleling options, or what it could be, right? It's not that it's limited to this amount of batteries. It's just giving you a kind of an idea of how flexible and modular we are with the eForce is. Um, so yeah, the maximum batteries you can stack on top are gonna be 3. Okay, anything over that, then you would just use a battery on the side. So you can do 3 here and 1 here. And again, given that each module has its own BMS, it allows you to do that, because the eWay is basically, it has a bus bar, so I can parallel those, and I will be basically paralleling without any issues with resistance or how current is being distributed across those battery banks. This is if you're installing in drywall, make sure you install the extreme sides of the bracket within the 16-inch of each stud, right? And then in between, we do have some holes in the middle. I recommend using this. It's actually what we used in Langhorne office to install the batteries for testing. And I actually used the toggler bolts, 265 pounds per bolt. But if you know, if you want to go a little bit more heavy duty, depending on where you're going to be installing it, you can also use 576 pound toggler bolts, and these is all you can get this all in Amazon, so pretty quick as well. All right, installation, floor mounting. Okay, things to consider. Each battery is 210 pounds per module, so it's a big boy. It's 9.6 kilowatt hours. So make sure you're using proper team lift. At least minimum 3 people. I've personally installed this with another person, but in order to comply with OSHA standards, we recommend using 3 people, or a special type of machinery that suspends the battery. And these batteries have a handle on each side. you can basically kind of use what do you call that? A machinery that will, extend some straps and hang it on the sides of the battery and then lift up, and then you can use that mechanism to install one battery on top of the other. When you're doing that, it's a one-man job for sure. Um, so special considerations is that, um, when you're taking the battery from your truck to the place of installation, make sure that you rotate it 90 degrees so this um, icon is facing you, right? So in this way, and that will allow you that when you're cutting the box, it's going to basically lift like this and down, and then you can just extend your hand and basically slide the battery out easy. And then from there, you can begin your installations, whether it's going to be wall mounted or wall fitted, easy peasy. All right, so um, floor mounting, right? That can be anchored or that can be floor mounted. Anchored, you would use the included bolts that would anchor into a 6-inch concrete slab, and you would be using these holes right here. But if you're not using a concrete slab, and let's say you're installing this in somebody's garage, then you would use the included legs, right? Stainless steel legs. Not to say that you can't use the stainless steel legs outdoors. You could just make sure that everything is, leveled, because that could create some conflict with the orientation of the battery, and then it can create some issues on the installation process, right? Like the holes not aligning, etc. Um, so install the stainless steel legs, then install the wall fitted bracket, and then everything is kind of designed sort of IKEA level. So each bolt that you use is gonna be referenced in the manual in each process. And it's also labeled when you get the bolt. It's going to be bolt B, bolt A, bolt C, and it's going to be referenced in each process. So basically, these will be the objects that you'll be using for this installation process. After that, then you basically place the base up against the wall, and then you align the template, right? So this background right here, which is basically showing that if you're going to use this configuration, right, place the template against the wall with the base against the wall, and you're going to start drawing, right? You're going to start making your marks. This template has little holes right here, and then these marks, like if I make a mark here, and mark here, all of those say wall floor fitted, right? And they're referenced again in the template. So once you make your marks, then it's, the real fun begins, right? You drill your holes, and then you can install in this configuration. And this is how it would look side to side, essentially, on the side view, sorry. If you wanted to install 2 batteries with an MB, this would be this configuration, right? You would follow this step. So basically the same thing that we did for the first configuration when it was 2 batteries. But then I'm going to take that template and raise it up, and then continue where I left off on the top. So right here, right? I'm going to continue here, and then I'm going to draw, or I'm going to mark um, according to the inverter that I'm using. So if I'm using the MV12K, or I'm using the MV8K or 10K, you mark in accordingly. So these 2 marks are with the MV12K. These 2 marks here are with the MV8K, 10K. And then this mark right here are basically the side brackets of the MV. Pretty simple, pretty straightforward. And then if you're using 3 batteries, you basically do the same process, right? So I'm going to take that template, right? Make my markings, and then I'm going to raise it so I can install the 3rd battery, right? And I'm going to use the wall floor fitted holes and mark it. All right. Once I mark everything, I start, like I said, you drill, and then I can begin my installation process, right? I put the base, make sure everything is leveled, and if it's not, the legs will allow you. Assuming that the floor is leveled, but let's say that the base is not leveled, this legs will allow you to basically level the base. Um, Once I do that, make sure that everything is leveled, then I would fixate the base against the wall and then install the battery on top, right? With the floor mounted brackets already installed and then secure with a side brace. Pretty straightforward. It's very simple. I'm not an installer, and I did the installation myself, and it turned out to be one of the easiest installations for sure. Um, and then you would do the same thing for the second battery. Okay. The connection between battery to battery is an Amphenol quick plug, so as you can see right here. So you install this battery on top of this second battery with already the brackets already installed as well. Secure the base and then, or secure the sides, sorry, and then secure to the wall. And then once you do that, you take the eWay, which weighs around 35 pounds, and then install it and secure the sides. And then you can begin opening, unlocking it with the security key. All right, installation, wall mounting. Wall mounting. So what we do is if you're not, let's say, give you an example. If you're not using, if there's not another battery, let's just say you're using one battery or two batteries and you want to wall mount both of them, then you just take the reference from the floor, right? All the way to, well, the minimum or the maximum was around 46 inches, and then you just mark your holes. But if you do have another battery, let's say you're installing in this configuration, what we take for reference is the from the base, right? From the bottom of the base, we measure 26.5 inches to the middle of the bracket, right? And once I make that mark, which would be this one, I can then begin marking using the template my wall mounted holes, right? And that will guarantee that this eWay aligns with this eWay. Again, everything is in the manual. We can reference back. Um, but yeah, if you have any questions, please leave it in some questions. I'll make sure I answer those during this session. Okay, once I install it, right? The wall mounting bracket, let's say I want to do this configuration, which is two batteries. I'm only going to purchase or use one wall mounting kit. Why? If I use two wall mounting kits and for whatever reason, I didn't, the customer did not drill it accordingly, then, you could create some issues in the connection, right? So by gravity, I am just sitting the second battery into the first battery, and the wall mounting bracket will be able to hold the weight of that battery. Okay. Um, so marking the wall mounting holes, right? And then I'm going to mark all the way to the top the wall floor fitted hole, and that will allow me to do this configuration. Okay, with one battery and one inverter, basically doing the same thing. We're going to mark these holes, okay, and then I'm going to raise the template, and I'm going to continue from here, right? And then install in this case, it will be the MV8K with the according holes. And the same thing for the MV12K, right? We are going to do the wall mounting holes, mark the holes, wall floor fitted holes, raise the template, and then continue marking the holes to allow this to achieve this configuration. Okay, once the holes have been marked, this is the process, right? You drill, install the wall mounting bracket, then install the battery brackets in this way. This is the battery, right? And then you're gonna anchor it into the wall mounting bracket as such, right? Starting from the bottom, right? It has some hooks on the bottom, and then you're gonna tilt to hook on top as well. So you're gonna hook in here first, and then you're gonna tilt towards the wall and then hook on top. Okay, and the last part will actually be installing the base. So I will install the L-shaped brackets into the bottom of the base, basically align it against the bottom of the eForce, mark it, and then drill, and then fixate back and secure the sides. Pretty simple. Okay, now if I want to install the MV, which is the newest iteration, is now available, right? The newest MV iteration allows you to basically dismount the bottom part of the MV, and everything is basically accessible. You can use the knockout holes, but if you want to use it with the eForce and have the MV sit on top of the eForce, this whole piece comes apart, and then the top part of the eWay also comes apart, and just basically the MV would sit on top of that. Okay, we do recommend using the basically the flexible extender to allow for going inside the eWay and as well as the inside the MV. So I drill the hole to put my wall mounting bracket of the MV. And I hooked on top, and then that's gonna sit on top of this eWay as such. And then you're gonna resecure the bolts that we took out. We're gonna resecure here, 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 and other bolts. So to make sure that it is sealed, right? So for no water ingress. Then I'm going to basically wire everything up, right? But this is a quick introduction of what everything is. It's the communication board on the eWay, right? You have your dip switches to allow you to select what inverter protocol you want to use, right? So it's dip switch 1, 2, 3, 4, right? And then I have the RJ45 ports, which are 4, right? It's going to allow me to do battery to battery communication, battery to inverter communication, battery to guardian communication, and then terminator, right? Similar to how you would terminate the communication on the eFlex. And then this would be a power supply for the guardian. So it's a DC power supply from the guardian. It's already connected. And the relay power output, right? So when I want to parallel battery to battery, I would use these ports, and they're all common. So you can use number 5 or 6. You can't go wrong. And this is basically an installation diagram, basically going uh, showing what I just described, right? So taking one eWay here, this is the communication board, right? Battery would communicate through this port, and this is all common as well. So you can't go wrong where you plug the RJ45 cable. This would be the guardian to the board communication, and then from there you have the communication from battery to inverter, right? So this side right here is MV, and this side right here is eWay, right? So this would be the battery to inverter communication going to the battery COM port, and then you have your terminator, right? And electrically, then you take the positive of the bus bar and use either a 3/0 or 4/0 wire, and then connect into the battery port of the MV. Same with the negative. And you basically do the same thing when you're doing parallel systems with eWays, right? From here, you would basically take the battery to battery RJ45 cable that's already included to parallel the systems. And then the terminator that was initially here now is going to be here to terminate that communication. And then you have your relay parallel cable as described previously. And then if you're using a 12K inverter, for instance, you can, since it has two ports, two positive, two negative ports. You can take the positive of this battery, put it in the first port, the positive of the second battery, put it on the second port, and do the same with the negative. And you're basically paralleling inside the MV as well. Since the bus bar is essentially bridged inside before it arrives to the breaker. Um, let's see. For the 8K and the 10K, you can take, that's going to be have only one port. You can take a pair of positive and negative, right? And then land on the first eWay, and then from there you can parallel using this bus bar to the other bus bar, since it has 4 ports, right? Easy. And this is essentially how your system will look like once it's all said and done, right? You have your positive and negative going into the MV, and then you have your communication cable going into the MV as well. Commissioning, okay? Flip the breaker of the MV first, the battery breaker on the MV first. And then we're going to turn on the switch on the eForce, right? If you have a standalone just like this, turn this switch. If you're having parallel systems, then you only turn on the master. The master is always going to be the battery that's going to communicate directly to the MV. All right, so I turn this on. I can leave this switch off, and this is going to propagate the information to these batteries to turn on and the communication information and the electrical power, right? Once it turns on, you're gonna look at the LED. The LED is gonna light up as such, right? And it's gonna boot up, and then you're gonna hear the internal contactors of the battery click on, right? So they're closing the circuit. Okay. So what does the LED mean, right? So if I go on number one tells you what the state of charge of the battery is, or this area tells you what the state of charge of the battery is. Number one is 25%, number two is 50%, number three is 75%, number four is 95%, and then number five is 100%. Now, this is considered one vertical stack of 19.2 kilowatt hour battery, but there is communication going from this battery to this battery. Therefore, if everything is well, then this should also stay on as well, right? And if there is a fault, then you would see frame 8 not light up, so it's going to be blank. What you want to get upon commissioning is this frame 8, frame 7, frame 6 all light up. And then the state of the charge of the battery, which is for shipping purposes, is around 20 to 30% to comply with shipping standards and regulation. We do recommend, obviously, once you commission the system, give it a quick charge to 100%, and then you can leave the premise. And you will also see a back light uh, basically flush against the wall. So there's some LEDs on the back of the battery signaling the status of the battery. So if everything is well, you will see green and green, right? So it's going to see green light here, because each battery is going to operate. They're operating in parallel, but again, you have that functionality that if, let's say, this battery is not functioning properly or there's a fault, then you can still operate with this battery, and then you will see this one light green, and then you will see this one light yellow. Okay, that means that there's a fault with the system. Okay, all right, now once you turn on, the LED of the MV is going to turn on, and then I'm going to bring a presentation. Oops. You guys can still hear me? Just want to make sure. Can you guys still hear me? Great, 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 great. Awesome. Perfect. All right, so you propped your LED. Now I'm gonna teach you the commissioning, like what are the different modes of operation on the MV that you can apply. I'm gonna go some of the basics. We're gonna go more in depth with others, with other applications. But for now, we're gonna keep it simple, right? All right, programming the MV via the LCD. First thing you're gonna do is basically make the system closed loop, right? Make your battery closed loop with the MV. All right, so this is the first thing you're gonna see when it pops up. Make sure that you update the LCD. The latest version right now is 19. And some of the modification that the LCD version allows you is number one, when you're doing multiple parallel systems, that inquires in that the power output or the power displayed is going to be was previously in watts. It's been shortened to kilowatts. So let's say that your system was consuming 100 watts. Now it's going to show zero point 0.1 essentially, right? The other modification is that now we've heard you, we've listened to you. I know that this was sort of a pain point, but now we are allowing 1 to 4,000 or and 1 to 6,000 uh, ratios, so you can get CTs that are rated for 400 amps or 600 amps. And we typically recommend Accu Energy. I will be releasing a technical note on the website shortly um, of how you basically install it, but our the default CTs that come with the MB are rated at 300 amps, but it's more for 200 amp panels, right? Um, but now that's no longer the case. Now you can basically choose a 400 or 600 amp CT, no problem. And this new LCD will allow you that. The other thing is to update the battery. The latest firmware update is 1F, 1F, and that will accept those CT ratios as well. First thing I'm going to do is put the system in standby, right? I'm going to put the system in closed loop, put it in standby. Every programming initial, you want to do it in standby. Now, if you're grid tied, um, basically putting in standby is going to do AC pass through, right? So um, basically the grid is going to pass through the grid port of the MV and then go out on the load output of the MV into the property, assuming you have whole home backup. The application is whole home backup. And then after that, I'm going to select the grid type and the frequency, and make sure you select set for every change you make, right? And then I'm going to select the grid regulation. Now, I would do this, the all three of these, I would do it at the same time and then click set, because essentially if you change the grid type regulation frequency or grid regulation or grid type, it will reboot, because then the system has to convert into what voltage is or what's the grid regulation or what the frequency is, right? So make these changes at the same time, so 120, right, or 208, depending on what your application is. So if your application is three phase, or 120 208 single split phase, it's also, oops, 60 hertz, right? And then select your grid application, or your grid regulation. Pico Rule 21, QIC, which is also Hawaii, UL 1741, IEEE 1547, and then PR Luma for Puerto Rico. Oops. And then I'm going to select lithium, and then I'm going to select lithium 18, right? And again, make sure you click set. And then I'm going to say, let's say it's a 19.2 kilowatt hour battery. I'm gonna select here 400 amp hours. And the reason why I do this, you don't have to, but the reason why I do this is if for whatever reason there is an issue with the communication, the cable broke, somebody stepped on, or you disconnected it, or whatever the issue might be, the system is going to default on the voltage settings of the system. Uh, in the LCD is called lead acid settings, but it's really another word for your custom settings, essentially. Okay, once you do that, Then you can disengage standby, right? You've already done closed loop with your battery and your inverter. Great. Now let's gonna commission the system in self-consumption mode. We're gonna put the system in standby, right? Okay. I'm gonna select my operating mode, right? Always I'm gonna operate in SOC. The discharge current limit, let's say I'm using a 19.2 kilowatt hour battery, which is 2 vertically. I can select 250 amps, which is 12K. And then the on-grid cutoff, I am going to lower it to however I want my battery to discharge. So for um, warranty purposes, we allow a 80% depth of discharge. So if let's say I want to, in self-consumption mode, I want to discharge from 100% to 20%, I would just here put 20%. All right. And then my off-grid cutoff, let's, for example, 15%. Okay. But when this battery reaches here, basically it's going, the system is going to switch from the battery discharging to the grid taking loads now. Okay. Okay. And then I'm going to click on zero export on the advanced section. Max export to grid is set to 0. And then that would be basically it, right? Also, one thing to note, you're working with one inverter, set your roll to one phase primary, okay? And then you can leave this phase as default, okay? And I will be going more into details as to parallel configuration. Make sure this charge first PV is disabled when you're wanting to work on self-consumption, because if you do have it enabled if you have it enabled or you have it enabled and you set a time, basically what the system is going to do is prioritize the battery's reserve, right? Or essentially not going to use the battery during that period, or if it's checked. So you want to make sure you deselect this, or let's say, I want to not use the battery during the day. Let's say, so I can set this to 6 a.m. and then I can put to 1800, which is 1800. I think it's 6 p.m. I believe 6 p.m. Yes, 6 p.m. And I can say, you know what? From this time, I just want to charge my battery. I don't want to use it, and the system is not going to use your battery, right? But outside of this time, so from 1800 to 6 a.m., it's going to discharge at night, which is some of the times a lot of applications I've seen use it that way, right? Um, and that's oops. Oh, and also make sure that you're not AC charging, right? So the AC charge is deselected. Um, and I'm going to deselect this, or otherwise you could charge your batteries based on SOC or voltage. So when my battery reaches, let's say, 25%, my battery can charge, right? If I select according to SOC or voltage, or let's say, you know what, I am now in, I self-consumed my battery, but I want to give it a charge during certain periods. You can select AC charge and then select the period and keeping it into account that it's a 24-hour format, right? Um, but yes, intrinsically, if you click on AC charge, then your system will not self-consume, right? Oops. Once you do that, you basically deselect standby, right? Oops. What's going on? Here we go. And then that's how your self-consumption mode would kind of look like, right? PV is going to homes. And if, let's say, the home load is more than what my PV consumption would be, then it would take power from the battery. Self-consumption mode is also applicable for properties or in uh, jurisdictions where the utility will fine you for exporting. So self-consumption would be applicable for those type of scenarios. Um, Backup mode. Click on standby. Oops. Yep. Backup mode. Click on standby. Typically in backup mode, you do have you're able to export, but if that's not the case, also keep it in 0 in the export. For the purpose of this one, I'm gonna do export to grid, and then I'm gonna choose how many kilowatts I want to export. It is controllable. I'm gonna select 12 kilowatts based on SOC, charge 250. This is good. Oops. I'm gonna disengage AC charge. And then I'm gonna have raised the on-grid cutoff to 90%. Okay, 90%, and then the off-grid cutoff to 20%. Now you will say, well, Matthew, I don't want to discharge my battery from 100% to 90% every day. Fine. You can do that by selecting charge first PV, and then I can select from 0 to 23, 2359. Oops. So basically, I have the system that is not going to use the battery at all 24/7 until there is an outage. Um, I do recommend, however, um, the battery cycles 10% every day. It's not mandatory, but it's better for the SOC calibration. If you have a battery, use a battery. Not using the battery doesn't necessarily going to guarantee more life because batteries, they within their chemistry, you need to use them, right? Some way, form, or another. So I recommend using 10%. Again, not mandatory. Um, but it's how I personally have used the system. And then this select standby, and this is how your system would operate, right? So I have PV, my PV supplying the loads, and all the excess is being exported. And then the battery's not being touched. Off-grid mode. Off-grid mode. Click on standby, right? Click on standby. All right. I'm going to select run without grid, right? Make sure you have your off-grid output enabled as well. Seamless switch, run without grid. Make sure you have lithium set up, lithium 18 as such. And very important that if you're tying a generator, make sure that the grid type of the inverter matches the voltage of the generator. So if you're using a 208 generator, use 208. If you're using a 120 240 generator, use 240 grid type 240 generator. And then the grid regulation is actually really important. So I would recommend using Rule 21 or PR Luma. And the reason is because, generator is going to have, depending how old or the generator is, you might have some voltage fluctuations or frequency fluctuations. And some of these equipments can be sensitive to that. So to open the range of voltage and frequency, we recommend using the Puerto Rico Luma setting or the Rule 21 setting so that the inverter doesn't disqualify the generator, essentially. But it's going to use those parameters. And then make sure you state what is going to be the DC current going from that generator to charge your battery. Okay. And then when you're stating what the rating of the generator is, you're going to subtract 20%. Essentially, what you're really doing is you don't want to over throttle the generator and potentially damaging the generator. So doing quick math, if you have a 10K generator, minus 20%, you're going to put here 8K. Okay. Now, there is a feature in the Envy and has the Gem Boost feature. So the Gem Boost feature will use, how do I describe it? So let's say you have an 8K or 10K generator. I put here a generated power to 8K, and just say you're running 4 kW, right? On your loads. Okay. So what the system is going to do is ignore the charge current limit if I enable Gem Boost, right? And it's going to take the remaining of and charge the battery. So if my loads are 4 kW, I'm going to take the other 4 kW stated here, right? That since I stated 8, and it's going to charge the battery. It's essentially what the trick is. So that means if my loads raise to 5 kW, then 3 is going to go to the battery. And it's that playful dynamic. Okay, once I do everything, I'm going to deselect standby. And this is essentially what your off-grid system is going to look like, right? It's going to look normal. I don't have any voltage or frequency from the grid. PV is going directly into my loads and then also charging the battery. Time of use, very important, time of use. Many jurisdictions, you have electricity at certain times of the day that are very expensive and some that are cheap during certain times of the day. And those certain times of the day that is cheap, you want to essentially use it to charge your battery. When it's expensive, you want to discharge from your battery. How do we do that? Okay, we're going to select, let's say uh, from 2 a.m. is very cheap, right? So I'm going to say 2 a.m. to 4 a.m., for instance, to give you an example. I'm going to select those times, click on AC charge, deselect according to SOC or voltage, and I'm going to charge from this period of time. Okay? And it's going to take into account what the AC charge power kW is. So if it's 6, it's going to use 6 to charge. Sorry, oops. All right, then I do want to touch my batteries. Let's say I want to have a reserve of batteries. I can use my charge first PV. As mentioned, when you select charge first PV and you select the time range, it's not going to use the battery. And then force discharge, right? This is the one that I'm going to use. Force discharge, and then discharge, let's say from 8 a.m. to 12 p.m., for instance, right? I am going to discharge from my battery, and I have to make sure that in order to accomplish that, I want to set this to as low as I want to go, 20%, right? 15%, 20%, to allow this force charge to take into account. And then I'm also going to specify the discharge power. So let's say 8 kW, right? And I want to make sure that depending on what my application is, if it's zero export, I'm sorry, oops. If I select export to grid, right? If I select export to grid, but I said that I want to force discharge the battery, 8 kW, the battery is going to offset my loads, and then any excess is going to export to the utility, right? If you do not want to export, let's say, zero net export, then it's going to take from that time that force discharge power, and it's going to discharge to the loads. But if I say I want to force discharge 8 kW, but I'm really using 4 kW, it's going to just discharge 4 kW into your loads. All right, parallel systems, and I know I'm running out of time, but I'll go this over real quick. Click on standby. All right, if I want to parallel systems, let's say this is the master, I want to make sure that this is one phase primary, right? And if it's three phase, then I would select, let's say you have three inverters, right? I'm going to select three phase primary. If I have two inverters in a three phase configuration, which we can do, you are going to select uh, 208 primary, right? And then I'm going to select for the master the R phase. But if you are grid tied, you can select auto detect phase once the grid is on, and it will assign it automatically. Okay. The subordinate, right? Let's say you have three inverters as we spoke. I'm going to select the subordinate, whether it's single split phase or three phase. It's going to be the second inverter is going to be subordinate. If it's three phase, I'm going to select the S phase. And then if it's the third inverter, I'm going to say, oops, subordinate. And then I'm going to say the T phase, right? If it's not three phase, if it's single split phase, then you can just keep it as default, right? And in parallel systems, this is the first step you're actually going to do before you do anything. In this way, you've basically synchronized all inverters, and then you can, by doing so, if you program the master, whatever you put, the information you put on the master is going to propagate to the other inverters. So you don't have to double or triple the work, right? When you're programming the LCD. And then deselect standby. And essentially that's how it will look like in the web portal or in your LCD, right? You're gonna see the voltage on all three, the frequency on all three, and how it's working as a one system. That will be all for today. I hope you enjoyed the presentation. I know we touched a little bit of everything. We talked about the eForce, installing the eForce, commissioning it, and then programming the inverter according to different modes of application. I will be looking at the questions. So you can parallel eFlex to eFlex and one connection to MV. I'm not sure, Milo, I'm not sure what you're referring to, but um, let's say you can parallel eFlex to eFlex. I'm not sure if you're referring to the eFlex Classic. If you're referring to eFlex Classic, we definitely recommend a bus bar, right? If you're talking, and then from that bus bar, you're gonna go to the MV. If you're talking about eFlex Max, the eFlex Max comes included with a bus bar already, so you would parallel, eFlex Max to eFlex Max with a flexible bus bar, and then from the eFlex Max Master, you would then go to the MV. Can we get more separation between those bus bars? Timothy, if you can elaborate on that, I'm not sure what you're referring to. I'm not sure if you're referring from bus bar for if you're pairing eWay to eWay, but I'll make sure to answer that question if you elaborate. Any additional protection needed when installing on an exterior wall uh, on the oceanfront property, such as a building structure, to cover any additional protection when needed to install an exterior wall on an installation fall property? That's a good question. I mean, this battery is IP65, so it is rated for exterior, and everything has been kind of essentially double, triple coated with non-corrosive or paint to prevent any corrosiveness or oxidation. Um, so I do believe it should be fine, but if I can get back to you on that one. I think I do believe we have other solutions when it comes to oceanfront property, but eForce would not be a problem. Okay, thank you. Thank you, Steve. Oh, okay. In the eWay, the plus and minus are extremely close together. Um, yeah, they are, but taking proper precaution, using ring terminals to connect on the bus bar, and from there you would shoot out on the side of the MV, and then from there you would shoot out up if you're installing the MV on top of the eWay. If you elaborate more on like what the concern is, I'm more than happy to answer the question. Uh, Florida, okay, flood zones. Can you show the wall mount at the required height? Florida hurricane zone. I guess what height the does that zone require? And we can go from there. But again, you can go a maximum of 46, so that's above 3 feet. Usually flood zones, that's typically what they require is 3 feet. So I think you should meet the requirements in that jurisdiction. Hmm. Do you need the eWay if you're only installing one battery? That's correct. You need the eWay to install the battery because it's gonna close the circuit on that module. So the eWay is gonna come with the base. So you're gonna install the base on the bottom and the eWay on top of the battery. What is the minimum modules you need? I mean, that just depends on what your load capability is, what your PV is, what the inverter is as well. If it's 12K, you need a minimum of two. If it's an 8K, uh, you need one. And if it's a 10K, then you need two as well. Kevin Bailey, how many cells are in an eForce battery? It's 15 cells. 15 cell battery. They are distributed equally. So you have a pack of five, a pack of five, and a pack of five. That's actually a good subject. I know that there's been some discussion between 16 cells, 15 cells, and that would be great for another webinar um, to go some of the differences, like what are the technicalities, and so on and so forth. Oh, I see. Okay, I understand your concern, Timothy. That they're very concerned. So actually, it might not look as it might not look as obvious, but you have one bus bar in the front and one bus bar on the back, and they're separated in this way. Um, so uh, the the short circuiting the battery is very minimal to none in terms of risk. All right, I think that wraps it up for all the questions. Uh, Jonathan Van, could you use? Yes, yes, you can. Absolutely. Mm, thank you all. I think that wraps it up. I'm trying to make sure I got all the questions, but feel free to NAPSET credits. Not on this one, but we will work on a training structure so that when you take the classes, you will get NAPSET credits for sure. Absolutely. Good idea. Uh, all right, guys. Thank you. Thank you very much. Have a great day. If you I hope I got to all the questions, but if I didn't, I will reach out to you through an email. Thank you.